Hi, welcome to another video on my Raspberry Pi with some electronics and a pulse width modulation motor. Last time I found out that the wiring PI pulse width modulation library is working perfectly when you use it on an LED, but isn't doing anything when you use it on a motor. Of course that was obvious for some time, but experiments last time and some search led to that definite conclusion. So I found out that I had to use RPIO PWM, which is hard pulse width modulation, which works through DMA, direct memory access. And there we come with also with change, because wiring PI is used through C++, while RPIO PWM is used via Python. And then I thought, okay, let me look in the past, and yes, I already made a small program in the past. However, this program is will not work because I haven't used the instructions in the correct way. So for now I will abandon the C++ and see how well the Python thing will go. Now these are some nice instructions, and it shows that I have to say, okay, PWM setup in a channel 0, and I will try to do this. Now you see here servo. I don't think my motors are servo, but I will use this anyway, since this is for the Raspberry Pi. So this should be able to work anyway. Having said that, it won't hurt to actually try out and test if my motor runs anyway. So I have to do a setup, an init channel, and then a channel pulse with let's just see 0, 17, 0 and 50, and then a clear channel, GPIO 0, 17, and a PWM cleanup. So let's go here and see. So I have here a GPIO setup, but since I have no idea if this is correct, I'm saying okay, I put it out. It works via setup, so I say PWM setup, since I assume that will be necessary for just once. Then I set up an init channel. Let me just follow the example, 0. Then add channel, and that would be a channel pulse, zero 17 160 I think, 150, 050. And everything has to be done with PWM. So clear channel GPIO 017 and a cleanup. Will this work? I have no idea. So for starters, let's just see if this is working anyway. GPIO motor1.py, very nice. No module named RPIO. So it looks like I still have to import it, so let's or install it. And they don't mention anything about this. So the question is, if it isn't still there, I may have to apt-get install it. Let's see what this does. No package RPIO. So well, on the Raspberry Pi this was already installed, and other packages can be installed by wget. But since this was just without installation, I assumed that it could go. So let's head back here. And it says Python modules, but then again, very nice. And here once again, but there is no way they don't say how to install it. So that's a bummer, and I have to find out how to do this. It is an extension to RPI GPIO, and if you notice, that does work. It just complains about RPIO. So this is a riddle. Let's check out how this riddle can be dealt with. After some searching, I found that I had to use sudo easy install to install RPIO, which it then indeed did. However, running this script again failed to do it again. So this is not really the solution. So let's get back at how it is supposed to look like. And here's a definitely in capitals. And here's a easy install, which it clearly does, or should have done. Getting back here, I can also say import RPIO. Would that do any good? I don't think so. Not really. So putting everything back again. So this is what it is supposed to be, and this is what the reality says. Not quite what I do, not quite what I like and what I want. So back to searching. After some new information, I installed it successfully this time, and in the process caught a few typos. So I got the GPIO motor 1 Python program running, and looking through the output using hardware PWM, and that is exactly what this is supposed to be. Increments time 10 microseconds. It does initialize channel 0. Pulses on, oh that's interesting, GPIO 17. Which is GPIO 17? I will have to find that out. So GPIO maybe with this headers and pins. So let's just see, GPIO 17 is pin 11. Interesting. Do I have it on pin 11? This is very interesting because I have to redo my wiring. It is start 0, width is 50, so that is all set up with this. Yes, in a GPIO 17. And so in this program I use two very different meanings. The RPIO is using the BCM, which means it uses the actual GPIO numbers, and then I'm referring to this GPIO 17, GPIO 27.
while the GPIO board, as I'm using so far for GPIO, is using these pin numbers. So when I use GPIO 17 in pin 7, I'm using this one. Pin 17 is this one. GPIO 17 is pin 11. Question is, which one should I use now? Do I have to get rid of something? I think I should. So what I can do is use this for lighting a wire, one of the LEDs I'm using, and then this for the motor, and see if that really does work. And then the width is then, I assume, the speed. So with all this set, it's time to wire, and then the point is then also I have to move this, because this is a while loop, of course. It makes no sense to have two parts of code. I will move this here. And then yes, so this is a clear, and I will put that right here. And then this is a setup in a channel, and then I would do this, say, here. Because the set mode is here, setup is here. That's interesting. I should make a little bit difference. So this should be it. Simple check. Right, no errors. Up to rewiring. I want to make this rewiring as logical as possible. So in 2 I have 2. In 6 I have 6. So that's all fine. What I now need is 11, which is GPIO 17. And I do need to keep the mask correct. So I am removing this line, and I am removing this line for now. This will go in 11, so 1, 3, 5, 7, 9, 11. 1, 3, 5, 7, 9, 11. Yes, and that will of course then go into lane 11. And that means that the plus of this motor will also go into the same lane. If alright, then this motor will start running. So let's see if that indeed works. Unfortunately, I do not see anything working. So maybe the wiring is not completely correct, but it says BCM, which is pin 11, but I can also look at pin 17, but pin 17 is just 3.3 volts, so there's no way that is going to be true, so it has to be pin 11, which is the 6th pin from the right. Do I have the 6th pin from the right? Yes, definitely. So with the 17 being correct, there has to be apparently more to it. And looking at the code on the in the example, there is nothing that says, okay, there's a sleeping. So I'm afraid there's some more to find out. It says an input value, it says a setup. That is an important one as well. How does it know that this is a setup? Alright. So apparently RPI 017 has to be set as an output as well. So let me just do that off camera. And it says just exactly the same, pin number and RPO out. So that is exactly what I'm doing, 17 and output. But on the other hand, that is done outside of it, outside of the loop. So I will do exactly the same. And start again. What happens now? An RPIO not defined. So I have to watch again to the code. So here I put in the same way as GPIO I did RPIO, however it's just a different numbering scheme, and what matters is that this is correct, and apparently it doesn't work quite like that. Let me save and run again. So this loop is being done. How about getting things out of the loop? Because it may even be that this is too much. So and even this is not entirely logical. So what do we do about this? Right, I completely disable this, leave this whole point out, comment out region, yes. Let's just handle for now. And the GPIO can also be removed for now. Let's just do the PWM. And it goes through it without a hitch. Is that clever to do? Well, there's nothing about this that I could see in the code. So I might have to check back on this, because this is going way too fast. And I think I know why it doesn't respond yet. The point is that these motors have frequency operating range or operating frequency range between 30 and 120 Hertz. So the pulse width and the period needs to be exactly in that range, that it equals that range. So what I have to do is a pulse to add a pulse width that equals exactly something in a range that equals 30 to 120 Hertz. Question is how to do that. Well, there are formulas for that, and I'll have to figure out how exactly that goes. Unknown territory for me yet, but I would love to get this correct. And of course I could say, okay, I make quite a loop with a range, and then I'll see with a certain width this number when it starts to run. That's empirical, could do as well. So but that also can take quite a while. So let me think on how that is going to work out. So not going empirical but calculating, then 40 Hertz is converted to pulses 1/40th, which means 25 milliseconds, because 1 Hertz is 1 period per second. 40 Hertz is 25 milliseconds. So this would then be, if in milliseconds, 25. However, it doesn't work. So, well, 50 doesn't work. And if I go to staying in the frequency range of 40 to 120, 25 would be adequate if it is in milliseconds. So let me try 25. And it didn't do anything. It may be too short. So let me introduce time dot sleep 1, and I didn't say from time import sleep, so I have to do time dot sleep. And it doesn't do anything. So if it is in microseconds, I have to add a few thousands. And there it goes wrong. So it is in milliseconds apparently. Nice to know. But the motor doesn't do anything. So I go to save. The middle of the frequency range is 80 Hertz. It's 12.5 milliseconds. Is this accepted? It is not accepted. So I make it to 12. And unfortunately the motor doesn't give in for a bit. Then if that is the pulse width is frequency, because if I look here, if I look here, it says just the modulation technique and anything that comes with it. So the period is the inverse of the frequency. Inverse. So that is exactly what I'm doing. Alright, changing to max frequency for now. 8 milliseconds or so. What I can also do is hold the motor and feel for any sign of life, which it doesn't. So I am doing apparently something wrong still. What it is, I don't know. I'm feeling I'm on the right track, but not quite yet. I'll leave it for now for this episode. So I had to do a bit of installation and download. I had to do a bit of rewiring, reprogramming. So far no error, but no success either. Thank you for watching. If you like my videos, please allow advertisements in between the video segments, or visit my website, which is listed at the start of the video and under this video, to find how you can use PayPal to support my website, blog and videos. And this story is far from over. So, to be continued.